Hey, welcome to the final short video lecture in AOOAD on the topic of design at the detailed system level. Today we'll be covering the topic of integrity constraints. This is a pretty short video, so bear with me. Integrity constraints refers to the rules that make sure that the data in the system is complete and correct. If we do not handle integrity constraints well, it may result in some pretty bad things happening. The system may not function correctly. There might be a critical runtime failure as the system tries to access a piece of data that's not there, or the performance may be inconsistent or indeterminate. Let's take a look at this example. We see that an employee is a member of multiple committees, and each committee can have multiple employees as its members. Additionally, an employee may be the chair of at most one committee, and each committee must have exactly one employee. This looks pretty simple, but there are various integrity constraints that must be considered. The first one I want to talk about is called referential integrity. And referential integrity ensures that a reference points to an object that exists. So, what happens if the chair of the committee leaves? Now, when that happens, you'll probably call the remove member operation. However, if the remove member operation does not assign a new chair to the committee, if the system tries to access the chair attribute of the committee when nothing is assigned to it, it might crash the system. This is an example of the importance of referential integrity. There's something called dependency constraints, and dependency constraints ensure that attribute dependencies, where one attribute may be calculated from other attributes, is maintained consistently. This is particularly important for derived attributes. In this example, we have the num_members attribute, which states the number of members in this committee. So the question is, if a member is added or removed, is num_members updated? Understanding dependency constraints tells us that whenever we add a member or remove a member, we must make sure to update the num_members attribute. Finally, we want to talk about domain integrity, which ensures that attributes only hold permissible values. If you base your reasoning solely on the class diagram, you will see that num_members is an integer. So, can num_members be negative? After all, there is such a thing as a negative integer. However, that doesn't really make much sense, does it? Another question we could ask is, must the chair of a committee also be a member? It makes sense that you can only chair a committee if you're a member of it. So suppose there is such a rule, and you wish to reflect that in the class diagram. How would you do that? Well, one way is to make use of something known as a constraint, which looks something like this. It's a dotted arrow from one association to another with a property that is placed inside braces. So this constraint says that the chair of a committee must be a subset of the member of a committee. So only employees that are members of the committee can be the chair. I told you this was going to be a short lecture. We're done! You made it! We've had 7 lectures on design at the detailed level. You're now ready to take that quiz on Mel. All except the last part of the password. The last part is not a letter, it's a set of instructions. You know the 6 letters that you got from the previous 6 lectures? You need to replace each one with the next letter. So if you got an A, replace it with a B, B with a C, and so on. And if you have a Z, you gotta replace it with an A. You should get a password that makes sense. Finally, here's a pot, a toe.